Part 1 is model setup. In this lab, we're going to set up a model water distribution system. It consists of a source on the left here, and that, for example, is a clear well, which I'm sure you went over in environmental engineering. Water is pumped into the pipe network with a pump that appears here. Each of these nodes and pipes has attributes that are on the next slides, and we'll go over those. And then there's a tank here as well. The pump has a rating of 650 gallons per minute at 150 feet of head, and the tank has a diameter of 60 feet with a height of 4 feet. So each of these pipes and nodes has individual attributes that we'll assign with it once we are in the EPANET software. Here are the attributes for each of the nodes, and here for the pipes. So we'll go into EPANET software in just 1 minute. Here's the EPANET software. You'll want to open it on your computer. You'll see a bunch of drop downs up at the top, different buttons in here that we'll be using. And we're going to take that sample water distribution system and now set it up in EPANET. We'll start with the reservoir. So you'll click up here in the toolbar on the reservoir to add a reservoir, and then left click again to place that reservoir. Next, we're going to add the nodes. So you'll click on the node button here, and we want to add each of these nodes or junctions in the order that they appear on your tutorial. So we'll put one here, and I'm going to click back on the arrow button and right click. We want to show the numbering so it's easy to follow. So you're going to go to the options and go down to notation and display the node IDs, values, link IDs, and link values so that we can see more easily and make sure we're setting this up how we want to. One thing I'll add here too is if you accidentally place something and want to move it, you can do so by just clicking, holding, and dragging it to a new location. So we've got node 2 here. We'll leave it right there and add the other nodes as they appear on the tutorial slides. Go back up. So we've got 2, 3, 4, 5, 6, and 7. So we're going to add node 2, node 3, node 4, node 5, 6, and 7. And next we're going to add the tank. So click on the tank icon again and place it there. Next thing we'll do is add the pipes. And again, try to follow, make sure we follow the numbers that are on the tutorial. It'll make it easier when we're adding the attributes and going through. So we've got pipe 1 connects nodes 2 and 3. Pipe 2 connects nodes or junctions 3 and 7. Pipe 3 connects, look over here, connects 3 and 4. We're just clicking on the start and end junctions to place these. Pipe 4 connects pipe 4 and 6. Pipe 5 connects 6 and 7. Pipe 6 connects 7 to the storage tank, 8. And pipe 7 connects 4 to 5. And here between 5 and 6 you'll see that there is a curved pipe. And to create a curved pipe, we're going to click on a few different locations along that pipeline to create that curved pipe. If you would like to alter your curved pipe at all, you can click on the pipe and go up to the top. You're going to click on it and right click on the pipe and go into vertices, and you can adjust these however you'd like to get a better shape on your pipe. Also, if you find out that you'd like a few more vertices to work with, you can add vertices, or if you want to get rid of some, you can also delete them as well. So we'll go back up to the top. Next thing we're going to add is the pump. So go up to the pump icon and you're going to connect 1 to 2. The direction that this pump is connected matters. So we want to make sure that we're pumping from reservoir 1 to node or junction 2. Okay? Next, we'll assign the attributes. So if we go back to the table that shows the attributes for junction 2, you can edit the properties of the junction by double-clicking on it, right-clicking, and then going to properties, or going up to the top here. I think the fastest way is double-clicking, so you'll double-click there. If you go to the table that has the junction properties, you'll see that node 1, or the reservoir, has an elevation of 700 feet. So we want to place that 700 feet there. And we'll go along, oops, that was junction 2. So we want to go back to make sure we put 700 in the reservoir. Fortunately for us, reservoir 2 also has an elevation of 700 feet. The base demand is 0. So we'll move on to the next junction, junction 3. A quick shortcut between the property tables for these is to use the page up and page down keys on your computer keyboard. If you go to 3, our elevation is 710 with a demand, meaning that there's a user there that's using 150 gallons per minute. You want to make sure you click outside that box so it saves that property. Go to junction 4, 700 foot elevation, and a base demand of 150. Junction 5 has an elevation of 650 with a base demand of 200. Junction 6 has an elevation of 700 with a base demand of 150. And junction 7 has an elevation of 700 feet and no demand. Finally, our storage tank. The elevation of the storage tank is 830 feet. We can set this initial level as well. We'll say our base demand is 0 at the tank. The diameter was 60 feet in diameter, and our height is 4 feet. So we're going to set the maximum level to 4 feet, and our initial level we can just set at 0 for now. And close that to save those properties. Pump, we need to assign a pump curve to. So to do that, we're going to go over to the right here and the drop-down menu that says Select Curves, and we're going to add a curve. So in here, you'll use the rating that was given, the pump specification, which was given as 650 gallons per minute. So we put 650 in flow for a head of 150 feet. And you'll see it generates a pump curve here. Hit OK to save that. And now we're going to click back on the pump and assign the pump that curve that we just created. So where it says pump curve, you'll put a number 1 to assign that pump curve to the pump. And close it. Now we can input the pipe attributes. So we'll go to pipe 1, and the length for pipe 1 is 3,000 feet with a diameter of 14 inches, and the roughness, which is the Hazen-Williams C factor, is 100. So we'll leave that as it is and move on to the next pipe. Same shortcut we can use here, page up, page down, to move between the pipes. Pipe 2 has a length of 5,000 feet, a diameter of 12 inches, and that roughness factor of 100. Pipe 3 has a length of 5,000 feet, a diameter of 8 inches, roughness 100. Pipe 4, 5,000 feet in length, and a diameter of 8 inches. These all have the same Hazen-Williams coefficient, so we're not going to mention it anymore. It's already in there. Pipe 5, 5,000 feet, diameter of 8 inches as well. Pipe 6 has a length of 7,000 feet and a diameter of 10 inches. Pipe 7 has a length of 5,000 feet and a diameter of 6 inches. Pipe 8 has a length of 7,000 feet and a diameter of 6 inches. Close out of there, save those values. Next we can run our model.